Welcome friends once again to the NPTEL MOOC module on exploring health survey data. We are on the week explaining on survey data analysis, discussing in this particular lecture on composite index. I am just giving you 1 minute background of composite index to start with. In research papers we know that if we just give the variable as it is, it may not have any analytical base, or it may not create interest for the readers to relate to the reality, and the in depth of the paper may not be well defined. Therefore, we need to define or develop certain variables which are composite of different variables. In reality, we have so many latent variables, so many variables which are not directly discussed. There is no single quantification possible just by the name of that variable. Suppose I say empowerment. Empowerment, if you look at that variable, it does not have any value directly. It is consisting of so many indicators. Okay. So, empowerment may be relating to decisions of the person, empowerment may be related to education of the person, empowerment may be related to the location of the person. Okay. So, there are so many indicators that those are consisting of or composing the index called empowerment. That is why empowerment is not directly observable, it is to be observed through different indicators and their weights. Therefore, we say these kind of variable called latent variable. And similarly, if we wanted to understand one variable called social capital. Social capital has strong bearing on healthcare expenditure. Okay. Social capital, you may refer to the person, how the person is connected, how the social value the person is bearing. So, it is networking, it is indirect, direct, its own education, the community development, etc., will be all composed together to define social capital. So, we are all going to discuss, we are gearing off to that extent and to give you the direction of understanding composite index, and also give you some practical background or practical steps to calculate and interpret composite index through PCA. So, let us move on. On the first slide, I will discuss about how this composite index is developed, what are the background of this composite index. Many socio-economic phenomena are complex and therefore difficult to measure and to evaluate. Complexity also implies multidimensionality. Okay. Development and poverty are two socio-economic important concepts that for a long time have been substantially regarded as unidimensional, especially by the economist. But in fact, it is not unidimensional, it is composed of so many dimensions. When you develop and go by only one aspect like development and poverty, it is in fact multidimensional in nature. So, the first that is development has been usually measured by personal income or by per capita consumption or product, while the second, that is poverty, has been measured as a lack of income or low expenditure. That is why those might be proxy, but not entirely discussing poverty. So, you might have heard about multidimensional poverty index, that is what is presently discussed in most of the policy documents. It is common awareness that a number of socio-economic phenomena cannot be measured by a single descriptive indicator, and that instead they should be represented with multiple dimensions. Phenomena such as development, progress, poverty, social inequality, I have already mentioned about empowerment, social capital, quality of life, well-being, provision of infrastructure, etc., are called latent variable, are not directly observed. Okay. And these require combination of different dimensions, and they considered together to define the word which we have just cited. These combinations can be obtained by applying methodologies known as composite indices. Okay. In fact, while measuring and assessing a given single dimension can be done with a single indicator, multiple dimensions require a set of various indicators. The fundamental question is what is the better approach to present or represent complex phenomena and multidimensional realities. The aim of the work is twofold. Firstly, we briefly discuss the main theoretical and methodological problems related to the multidimensional analysis of development and poverty. Secondly, we consider the need to build a composite index or composite indices of these two variables that have been already discussed, and we will be including its desirable properties. The most suitable method of constructing composite indices depend on the following factors, that is type of indicators, maybe substitutable or non substitutable, type of aggregation, simple and simplex, type of comparison to be made between relative and absolute, type of weights of the indicators, maybe subjective or objective based. Building a composite index is a delicate task and full of pitfalls from the obstacles regarding the availability of the data and the choice of individual indicators to their treatment in order to compare or normalize after with its normalizations and aggregate them with the help of weighting and aggregation. Despite the problems as mentioned, the composite indices are widely used by several international organizations in measuring their environmental, economic, social context, which therefore provide an extremely relevant tool in the course of evaluation as cited as mentioned by OECD in 2008 definition. There are different steps involved to construct a composite index as suggested by Majoita and Pareto in 2012 paper. First of all, defining the phenomenon that is to be measured. The definition of the concept should be a clear sense of what is being measured by the composite index. Then selecting a group of individual indicators, especially we need to take care of their relevance, analytical soundness, timeliness and accessibility, etc. A statistical approach to indicators choice involves calculating correlation between potential indicators and then including the ones that are less correlated in order to minimize the redundancy as suggested by Salzman 2003 paper. Normalizing the individual indicators are also important. The steps that aims at making the indicators comparable with the normalization, these involve these are important. It is necessary to bring the indicators to the same standard by transforming them into pure dimensionless and numbers. It has to be comparable, it has to be completely having certain scale, it should be unit free. Okay, then only those can be made as a composite index. We want to normalize the indicators so that an increase in the normalized indicators corresponds to increase in composite index. There are various methods of normalization such as ranking method, rescaling with the mean maximum transformation, then standardization with this Z score, mean the score minus the mean divided by standard deviation, and indicization that basically some forms of index transformation is required, maybe like distance to a reference, how far it is, and accordingly some forms of transformation is required for comparison. Aggregating the normalized indicators is the next step. It is the combination of all the components to form one or more composite indices having its mathematical properties, functions. Then different aggregation methods are possible. The most used are additive methods that range from summing of unit ranking in each ranking of the indicators to of each of the indicators to aggregating weighted transformation of the original indicators. Multivariate techniques is called principal component analysis are often used, okay, as also cited by this author. no universal method exists for composite indices construction. So, we should not just just not be confused that these indices or the composite indices is the best or the worst should not be used. So, you need not get yourself confused, there is no such single universal method that is widely accepted by all. Rather, PCA to a large extent is widely used. In each case, their construction is much determined by the particular application, including both formal and heuristic elements, and incorporate some expert knowledge on the particular phenomena. Now, I am citing one study of ours, one of our projects published by National Institute of Rural Development and Panchayat Raj institutions. They funded this project. Our team calculated, and this is in the public domain. I have already given the link here. You can cite the page number 111 to 112. That is on MG-NREGA convergence activities. Okay. So, where we have discussed about PCA, principal component analysis, that PCA transforms the original set of variables into smaller set of linear combinations that account for most of the variance of the original set. If there are variance already attached in the distribution of the variables, so those are actually normalized, okay, and the most of the most of the loading of the variables are considered in constructing a PCA index. It constructs out a set of variables like J's varies from 1 to k with new variables. They are named as PCI 1, okay, PCI called principal components, which are linear combinations of these Z availability, the kth availability of the J variables. You can also refer to NFHS 3 2005-6 report. This gives detailed discussion on PCA as well. Procedures for the construction of the indices are specified as below. Here the coefficients that is A or alpha are called factor loadings. So, accordingly the principal component scores are defined. Okay. In the present context, as per the project report or project variable, the first PC, that is the principal component, observes and accounts for maximum possible proportions of the total variation in the set of all variables. First of all, we need to do some factor analysis. Then if there are so many factors, if you do not have so many factors, then directly you can consider those variables, okay, and try to normalize the variables wherever there are some possibility of extreme values, okay, make the distribution more normalized. Okay. Then this first PC observes and accounts for maximum possible proportion of the total variance in the set of all variables. The study considers factor loadings that correspond to the first PC to derive different convergence activities and impact assessment index. We actually developed convergence activities index and impact assessment index, because the project was on impact assessment of convergence activities in MG-NREGA. The nature of convergence activities among the beneficiary households in the study area is classified into 8 areas we identified, that is socio-economic characteristics, asset types and sustainable asset creations, asset usefulness and quality, awareness and participation, wealth index, socio-economic impact, in short we have mentioned as SCI, then ecological impact, ECI, and empowerment impact as EMI, etc. The impact is best understood from a single weighted composite index, okay, that is here as per the report is called impact assessment index, which considered these 3 important aspects, SCI, ECI and EMI. These are the things I have already mentioned. PC score for each of the above dimensions is computed by applying the following method, a summation of ZI AI, their factor loadings, okay, I vary from 1 to n. After calculating PC scores, range equalization with equal weight is used to derive index values. That you need to also mark very carefully. Range equalization is made because because of having proper scaling of those variables without having much deviation from the central mean, and with equal weight has been considered to develop the index. This involves a multi-stage process. The steps involved are like first the range equalization is conducted on these PC scores of each dimension, which requires the subtraction of minimum value from the value of each dimension and by dividing the same with the difference of the maximum and minimum values. So, basically the equalization technique which we used to discuss. So, range equalization ensures that all variables lie between 0 and 1. Okay? That is why we said we need to make first of all about those variables with range equalization. Then it is like x minus minimum value divided by maximum value minus minimum value, this divided by this. Okay, so, this is what is called range equalization. So, range equalized variables are aggregated with equal weights to create the indices of respective parameters. Overall impact assessment, that is indicated as W1 is equal to SCI indicators, that index plus its weight. Basically this is multiplied here, it should have been taken, this is in continuation with this you can just read along with this. Okay. So, W1 it is weight of the first indicator, then weight W2 is the weight of the second indicator, and W3 is the weight of the third indicator. So, these are again these weights are all equal, equal weights have been considered. Then this is impact assessment is applied to the beneficiary responses accordingly, how much impact assessment have been attached to each of the beneficiaries. We will also give practical handouts here for your better reference. So, the type of indicator which have been discussed we will also reiterate. We are now guiding on choosing the best method. On first of all on type of indicators, it is one of the main factors that affect the choice of the aggregation method. The components of a composite index are called substitutable. If a deficit in one component may be compensated by a surplus in another. Similarly, the components of a composite index are called non-substitutable if a compensation among them is not allowed. For example, a low value of people who have participated in religious or spiritual activities can be offset by high value of people which have participated in meetings of cultural or recreational associations, and vice versa. And another one is on a low value of hospital beds per 1000 inhabitants cannot be offset by high value of medical doctors for 1000 inhabitants, and vice versa. So, so we can define an aggregation approach that is compensatory or non-compensatory depending on whether it permits compensability or not. A compensatory approach in fact involves the use of additive methods such as the arithmetic mean we usually use. For a partially compensatory or non-compensatory approach, non-linear methods are generally adopted such as the geometric mean or the multi-criteria analysis, they are also adopted. Okay, so then type of aggregation is important. The choice of the best aggregation method also depends on the aim of the work and the type of users. Okay, so type of users may be researchers or the general public. Generally, an aggregation method can be considered as simple or complex. We say that an aggregation method is simple when a easily understandable mathematical function is used. Let it be we are going to discuss about Human Development Index. On the contrary, aggregation method is said to be complex if a sophisticated model or multivariate method is used. Okay, that is principal componental analysis. So that actually includes multivariate methods based on factor loadings as well. So, type of comparisons should be made, that is data normalization firstly depends on the type of space time comparisons between absolute or relative. Standardization or transformation Z-score permits only to do relative comparisons. This is what we have already discussed. Then you can just read between the line. Other methods such as rescaling, indicization, indexation requires that the definition of extreme values or the base are independent from the data to perform comparison or in absolute terms. That is what SDI stands for, and we will be also discussing this in detail. What kind of weights are considered? The question of the choice of a system of weights to weigh the individual indicators according to their different importance in expressing the considered phenomenon necessarily involves the introduction of an arbitrary component. The easiest way is to assign same weight to all components, that is equal weighting method. In this case, the most suitable normalization method is the standardization that brings all indicators to have the same variance. Alternatively, subjective weights can also be given based on the loading of that particular group, okay, and usually policymakers give and in social surveys about how important individuals indicators are to the people in specific indicators. Finally, an objective weighting can be used, choosing a methodology that assigns a weight proportional to the variability of the indicator. You might have seen this variability weighting is done in different large scale data set like NSS and FHS. Indicators with a low level of variability will have less weight, and indicators with a high level of variability will have much more weight. We need to note here that although we are using a simple mean, it is possible to weigh implicitly the indicators through an appropriate normalization function. Here I am citing the best method that is to be chosen in developing index. Next is on SDI, how they have followed the path. So, one we have already discussed based on types of indicators. There are various mixed methods involved. First of all, it is the type of indicators is based on substitutability versus non-substitutability. Then this is so based on substitutable indicators, they are called compensatory method, or otherwise it is called non-compensatory method. Then we should go for type of aggregation that we already discussed, and accordingly if it is complex then PCA is most used, else simple mathematical arithmetic mean is applied. In case of non-compensatory method, in their aggregation, simple geometric mean is also perfectly fine. In complex case, and it is called multi-criteria analysis called MCA not as only PCA. Okay. So, then we need to go for type of comparison. This is the first indicator, this is the second one, this is the third one. Okay. Comparison, whether it is based on relative method or it is absolute weighting method. So, relative, where we are supposed to discuss about the weights, whether it will be subjective or objective. Similarly, in case of absolute method, subjective and objective method could be adopted. In case of relative comparison, in the subjective weighting method are called rank, Z-score, mean max transformation. Similarly, in absolute one also mean max transformation is also used. Okay. Then in case of objective one, index number transformation or endogenous base method are also used, but in case of absolute one, index number, but exogenously determined weight can be given. This is how the path of human development index is followed. All those explanations are given, how they have finally followed, and this is highlighted in the color. So, at the end, after explaining all such things, the mean max transformation method has been followed, and the absolute weighting approach is also followed. And most importantly, instead of making it complex, they have used a simple method for aggregation. Okay. and they are non-compensatory method because the indicators are non-substitutable. Okay, so this is what the weighting or the composite index has been developed in HDI. Now we are going to have some practical sessions of estimating PCA and how this could be interpreted. I will then come to discuss about some differences you can make after understanding this particular information. Okay. So here we are opening one practical sample data on the screen through Stata. Okay, the Stata, the sample Stata subscription you might have all downloaded for 1 week. You can just save it and then operate with that sample version. So the data we have opened, the data we have taken from a field survey, okay, from a primary field survey. It's maybe you can say for you it is arbitrary, for us it is the genuine one. So now we are going to discuss about its do file will open, how the index is developed. Okay, we will be including those 4 variables. First, what you need to do, you need to actually define this PCA, right. So you need to define these 4 variables. Here we have actually defined how we have defined. Let me just mention you. This PCA is going to give you information about its factor loadings, eigenvalues. Okay, usually with higher eigenvalues that components are considered to be having highest variability in the model. Whichever the eigenvalues is exceeding more than 1, they are considered to be having highest loading, and there are principal components derived based on those eigenvalues. Each eigenvalues are a kind of loading, okay, a kind of weight. So then what we will do, we will go for, after defining all those things, the system is going to read its scores, predicted scores based on those factor loading. So we will now operate the predicted score on your screen. So these are the predicted score. These predicted scores, like you can compare this principal component with the eigenvalues, okay, eigenvectors. Based on the eigenvectors, these this one, the simple principal components have been considered as the principal scores. Okay. Then what we will do, we will in fact discuss about we will try to tabulate those scores once. How these scores look like starting from the end, and we have the observations in our sample study of 100 observations. We are just mentioning this. What is this all about? You need not understand what are those variables, like we try to understand the consumers' perceptions, the individual perceptions about healthcare. Okay. So are you overall satisfied? Just one variable I am just trying to understand you. I am just taking tab. Okay. Each of the variables are here as is mentioned. Okay. You can just have a look. Do you have confidence in medicine prescribed through online prescription? Here it is as do you find digital healthcare services as acceptable the way it is getting placed? Are you overall satisfied with the quality of services being provided? Okay, so now we are calculating the scores after discussing all those things. Here I am now going to summing up those scores. The summary statistics of those scores are calculated here. Okay. So summary, this gives us the mean values, number of final valid observations, then its minimum, maximum values all are here. Then we will go for explaining. As I already told you, then next step is to define the normalizing the score. A range equalization technique should have been obtained. Here we have applied the min max strategy technique, that is score minus minimum divided by maximum minus minimum. Okay, so this is the one we are operating. So 4 missing values are there. So 4 were not generated. Rest 96 based on the 96 valid observations. The normalization data has been defined. Now again we are going to summarize it. summarize the new variable we have defined as digital health, or in short called DG health. Okay. In the summary, you can just see the mean expenditure, then mean score, not expenditure, mean score related to perceptions, their standard deviation, their minimum maximum values. Now all the values have been considered between the range of 0 and 1. Now we are going to define or scaling it out of 100 instead to define an index. So we are multiplying with 100. Okay, so we have defined these. Once again we can also summarize. Now you can see 100 will be your maximum score and 0 will be your minimum score. Okay. So minimum and maximum, since we have multiplied 100. Now we are going to tabulate that once again. We just want to see how it looks like. Okay. Initially it was in fraction, now it is in some absolute values. So we are now making the index. So the command is here is called xstyle, okay, with a new variable name we have defined we are defining in quintiles. This index in 5 categories. Okay. Index is a number, fraction of number, okay, but we are categorizing into 5 quintiles. Okay. So NQ5 is given. If you want to keep it is 3 categories, then NQ3 has to be site mentioned. So at this moment it is 5, we are just running it, and you can just see and how it looks like. We are going to tabulate and get the frequency distribution of it. So here it is on your screen. So these 5 indicators are on your screen. We have defined the the composite index called DG health in quintiles. Okay, there are 5 categories, and each category is how much the percentage of it, how much in each category, you can easily understand. If you are still a bit confused, you can refer to NFHS 3 round and how wealth index is defined. Okay. Wealth index they have defined into 5 quintiles. Okay. So in which quintile, whether a lower section of the society having having highest frequency or higher, whether the middle incomes are having higher frequency or not, you need to get yourself confident, and they have applied the PCA techniques. Okay. So after saying so, I am once again going to open off the discussion to one of the sophisticated modeling we usually do, which is even better than the simple PCA. Here I am just clarifying it using the ISDS data, ISDS second round data of 2011-12. Information available in that round is on social capital information. There are so many indicators of social capital. We are discussing in our paper on social capital index for healthcare access, how social capital is impacting healthcare access. Like if a person is located in rural area, that person may not individually satiated with the kind of healthcare is being provided. The person might get huge information about the availability of the healthcare facilities in their locality through their Gram Panchayat, through their village leader, through their educated persons, maybe through their teacher, school teacher. They get to know about ASHA workers and their implementation. They get to know about vaccination during COVID-19, whether this is available or not. So healthcare access is well modulated or well developed or understood, penetrated to the last mile through social capital. So we have developed a social capital index based on 4 important indicators as available there. You can also modify, there is no standalone index. Here I am saying there are possible direct social network, indirect social networks, educational attainment, decision making. Direct social networks, the persons who have directly know the person, maybe directly involved as a teacher, maybe directly as a politician or member in Gram Sabha, etc., attending Gram Sabha. Indirect social network, where they know they have certain acquaintances with those top people. We have, I am not mentioning the exact variables, you can go through an ISGS 2. There are 12 variables given in this direction, though they have been written as direct or indirect, we have defined it. I am not clarifying all the detail at this moment. If you have difficulties, we will address that at our live session or in our chat box. There are 3 variables here, 2 variables and 6 variables. we know that we should have given equal weightage. So, since in total we have 1, 2, 3, 4 indicators. So, 1/4 is our actually weight. Okay. 1/4 times 12 indicators are there. So, 1 upon 12. So, the weight of each of the indicators under direct social network is of 1 of 48. Okay. Similarly, in the second case each of 1 is having 1 of 12th, then 1 of 8th and 1 of 24th. It seems as if there are differential weight but differential weight by each of the indicators, but equal weight by the broad indicators, right. So, that is what you can interpret, you can convert that variable with adding or multiplying this 1 by 48 against that one, then finally you run this PCA technique that we have just discussed. That will be given you, will be defining you the social capital index, and will be very robust so far as your model is concerned, for avoiding multi-quantity issues, for getting better R square values. Your model interpretation is going to be much better and usually accepted in different journals. These are all details for at this moment. We look forward to your participation in the next class. Thank you.